wanted to show you some of the stuff that I've been learning. Quaternions in specific. What are they? They're imaginary numbers in three-dimensional space. Quaternion math was invented by this dude, Rowan Hamilton, some Irish mathematician in the 1800s. And it's basically rotation vectors to figure out a position of something in space. And basically it's a math equation to figure out, like I said, just something's position in space. It's either its angle, or its yaw position, or its roll position, or pitch angle. So if you're interested, you can look it up. But what am I doing? What can you do with these things? What am I doing with it? Well, if you use them in a microcontroller, coupled with an accelerometer, a magnetometer, and a gyroscope, you can make yourself an IMU. What's an IMU? It's an inertial measurement unit, and it tells things where they are at in space. They use them on like helicopters and rockets and things for position and just for location and control, basically. So what I got here is a microcontroller. It's in this box, and right now it's spitting out all of these values that you see here. There's four of them. There's four columns: I, J, K, and an H. And these are quaternion values. So whenever you rotate this thing around, you can see these numbers going wild. Well, these are raw numbers. The quaternions these are the raw numbers being spit out of the chip on this board that does a lot of the heavy lifting as far as math. So for quaternions, and it spits out this value for you. And what can you do with this value? What do you do with quaternions? You can take a quaternion, and using Mr. Hamilton's math from the 1800s, you can calculate a pitch or a roll angle, and that is an Euler angle. And that's in simplest terms, it's basically like a digital level. If you had a digital level and you set it on a surface and it said 22 degrees, and these values changed, and then it calculated to 45 degrees. So that's the simplest term. So what am I going to show you here? What is interesting about this? So right now, this microcontroller spitting out all these values. It's just sitting still on my desk right now, and I'm going to shut this down, and I'll show you here. Well, if you want to go wiki this stuff, it's all there. Everything you need to know. How to take a quaternion and turn it into an Euler angle. So I have two different sets of code here. On the left, I have Python code in a Python scripter that is interfacing with the microcontroller, and I'll show you here in a second what this does. And on the right here, this is C+ code. This is the code in the microcontroller, and this is taking the values from the quaternions from the magnetometer, gyro, and accelerometer, and it's basically spitting them out in a raw value. So these two things it's two different things going on here. So just think of this thing on the right as what's in the microcontroller that I just showed you, and think of this on the left here. This is the PC, the computer that I have in front of you. The computer is using this code over here, and I'm going to show you what it's being used for. So if I run this bit of code here, if it works right, you see on the screen here this little widget that looks like a square. And hold on one second. Okay, so we had a little USB issue there. So you see this thing on the screen here, and this is our vectors here: north, up, down, left, right. So if I hold this up in front of you, you can see when I tip it, it rotates, follows along with this. And if I do that, and you can see the red, green, and blue arrows that are stationary, that aren't moving. Those are exactly that. That's a coordinates position system that's stationary, that tells you where Earth is, or not Earth, but something is non-moving. And the coordinate system on the device is the other longer, thinner green, red, and blue arrows. So anyway, so right now, this interface, what you see on the left here, this code here, is what's creating this object. And this is in Python scripter, and you can draw out these boxes, and that's basically what I did. I coded this on the left here. I designed a little square box, and you can see up in this area here, here's the arrows. I drew out the arrows for the length. Here's the red arrow, and its vector axis is which way it's pointing. Here's the Y arrow, and it's the green arrow, and this is what vector it's pointing in. And here's, the front arrow. These are the two different sets of arrows that are on there. And then here's the board. You see this thing that says board? This is the square rectangle that you see rotating around. So it's 2.75 inches in length, 1.75 inches in width, 3/4 of an inch in height, and it's opaque because you can see through it. And that's what position it sits in, stationary. And then here's a little box, that little green box in the center. That's the main chip. We just drew it, and here's the length, width, and height of that chip, and we colored it green. So if you look here on the screen, this is the little green box, and this one. So anyway, we just programmed a little box as an object to use to rotate. So anyway, that's what this code does. This is virtual Python, and lets you program stuff in a virtual world, and objects. If I wanted to, I could make this a car, a motorcycle, who knows what, whatever. So anyway, so this is Python side of it, and this is how game developers interface with controllers. And I think if you think about it, there's a lot of things on the planet you touch these days that have this type of control in it, your phone, all sorts of things. So anyway, Python on the left here. Now, what am I going to do with this thing? Now that I got this, it's pretty neat. At least I think so. I spent a lot of time putting together all this code and learning new stuff and how to program. So it's not my background really, but I've been muddling through this for the past 6 months, and we're almost at the point where we got something that's pretty cool. So anyway, the microcontroller's over here on the right. So now, what do I do with this over here? I mean, I can't really do much with this if I was building a game, or something. Who knows what else I could make this interface with a PC, but I don't want to make it interface with a PC because that's not my end goal. In the code over here, I have it all being ran on the microcontroller to spit out the Euler angles, and it's just simple math equations. If you take the quaternions, and like yaw is the arctangent squared of these quaternions multiplied against each other, added together using Hamilton's math, and pitch is the arc sine of the quats, and then rho is the arctangent squared of the quaternions. And this is pretty, long math equation, but it works. And if you want to rotate around, if you're, need to change your yaw position 90 degrees, you can multiply it by pi, and this is what this is a rotation right here. This is a pi times the yaw vector. And then what happens? So you get these quants, you turn them into Euler angles, because this is an Euler conversion, turns it into angles and degrees. And then what do you do with them? Well, let me show you. This is where it gets really neat for me. So let me kill this program. Okay, 1 second, I can unplug this. So I gotta unplug this little widget and I have to plug it into something else here. So, moving over here, now I've plugged it into this. And this is into my Motec Dash, now you can see it. So, within this code, within this code up here, that's running on a microcontroller, along with what it all else is doing, is creating angles that you can be reported, and then it's transmitting them over CAN bus. So there's CAN bus code in here that I wrote that sends and messages everything over a CAN bus. So there's actually a chip in this device that is a CAN chip, and that, if you send out over CAN, there's some wires coming out of this thing right now. 4 wires. There's a power and a ground and the CAN bus. So I can connect that CAN bus, those 2 CAN bus wires, to this dash. So this is Motec Data Logger Dash, and it's very not simple, but you just send over CAN bus your hex values, and as a, take your Euler angles, convert them to hex, and then ship them over the CAN bus to the dash, and then in the dash you say, okay, receive this value hex and display it, and you can log it, and you can do with it whatever you want. So if you see, I can take this thing and I flip it around. I got the little screen thing here, widget, so that it reads angles. So there's 45, that's 0, there's 90, there's the other way, there's 90, and then there's yaw over here, which, well, it's not going to be reused for a whole lot, but if I rotate this thing around, on the table here, you can see the yaw rotating. So this has consumed many hours of my life for the past, since we've been sitting around being couch potatoes and not allowed to go out of our houses because everybody's afraid to get sick. So I put the time to some good use, and made a neat little project here, and there you have it.